Hello. Dear students of class 10, we are going to solve mathematics by R.D. Sharma, chapter 1, exercise 1.1, real numbers, example 12. So if you follow all of my videos, you can score good marks in board examination. So the question is, so that one and only one out of n+2 or n+4 is divisible by 3 when n is any positive integer. So when we divide any n integer by 3, so we have positive integer of positive integer of form when divided by 3, then we are getting either 3q or 3q plus 1 or 3q plus 2 for integer q. So there is only one of these possibility can occur, either 3q or 3q plus 1 or 3q plus 2. So we have cases, three cases from 3q, from 3q plus 1 or 3q plus 2. So we have three cases. So case 1. So n is equals to 3q. So when we will add n plus 2. So n is equals to 3q means there is no remainder. So it is divisible by 3. So n plus 2 means we will add both sides by 2. So there is a remainder 2. So n plus 2 is not divisible by 3 as it leaves remainder 2. So again we will take n is equals to 3q. So again we will add both sides plus 4. So 3q plus 4 as given in question. So we will take common. So this can be written as 3 plus 1. So 3 will be common. So we will get q plus 3 1 ja 3 plus 1. So again we are getting one remainder as 1. So n plus 4 leaves remainder 1 when divided by 3. So it is not divisible by 3. So from case 1 we can write that n is divisible by 3. However, n+2 and n+4 are not divisible by 3. So we can see only one is divisible by 3. So in the question it is given so that one and only one out of n+2 and n+4 is divisible by 3. So we have done with the condition in case 1. So moving towards case 2. So we will take n is equals to 3q plus 1. So it is not divisible by, so we can write that n leaves a remainder. So this is remainder 1 when divided by 3. So n is not divisible by 3. So again we will take n is equals to 3q plus 1 and we will add both sides plus 2. So n plus 2 is equals to 3q plus 1 and we will add plus 2 because we are adding both sides. So n plus 2 is equals to 3q plus 3. So n plus 2 is equals to 3 is common. So q plus 1. So there is no remainder left. So we can write n plus 2 is divisible by 3. So again we will take n is equals to 3q plus 1 and again we will add both sides by 4 as it is given in question. So it is plus 4. We have added both sides by 4. So n plus 4 is equals to 3q plus 5. So n plus 4. So this 5 we can write as 3 plus 2. So 3 we will take common and q plus 1. 3 1 ja 3 and plus 2. So there is a remainder 2. So we can write n+4 is not divisible by 3 as it leaves a remainder 2. So we can write that from case 2, n+2 is divisible by 3, but and n+4 are not divisible by 3. So pause and write the solution. So moving towards our next case, case 3. So we will take n is equals to 3q plus 2. So there is a remainder 2. So we can write n is not divisible by 3 as it leaves the remainder 2. So again we will take n is equals to 3q plus 2. So we will add both sides by 2. 3q plus 2 plus 2. So we will get n plus 2 is equals to 3q plus 4. So we can write 3 plus 1 to take 3 as common. So n plus 2 is equals to 3. 3 is common. So 3q plus 1 plus 1. So we are getting remainder as 1. So it is not divisible. So we can write n plus 2 is not divisible by 3 as it leaves a remainder 1. So we will again take n is equals to 3q plus 2. So again we will add by 4 as given in question. So 3q plus 2 plus 4. So n plus 4 is equals to 3q plus 6. So n plus 4 is equals to, so we will take 3 common, so q plus 2. So it is completely divisible by n plus 4. So we can write n plus 4 is divisible by 3. So at last we can write n plus 4 is divisible by 3, but However, n and n+2 are not divisible by 3. That's all for this question. This question was solution was long, but it was easy to understand. So thank you. If you liked my video, please subscribe to the channel. And if you have any doubt, drop in the comment box. I will try to solve your doubt as soon as possible. And if you follow all of my videos, you can score good marks in board examination. Thank you.